Hi everyone, it's Coach Fred here, and today we're going to be going over the properties of parallel lines, which is section 3.2 in your textbook. And so what I'd like you to do is do the warm-up. There's a few problems. I'd like you to identify all the special angle pairs in this figure. So press pause, try it, and let's just come back and review that, okay? All right, so same side interior angles. So these are the two lines, and S is the transversal. So then 5 and angle 3 would have been same side interior angles. Alternate interior angles would be angle 4 and angle 5. How you doing so far? Okay, corresponding angles are in the same relative location to the transversal. So 7 and 6 are corresponding angles. Hopefully those felt pretty good for you. Number 4, 8 and what are corresponding angles? Now remember, they have to be on the same side of the transversal in the same relative location. So it would be corresponding to angle 5. Angle 4 would be alternate interior to angle 5 as well. All right, then in naming the angles, 3 and 7. All right, so they're on the inside of the two lines, but on opposite sides or alternate sides of the transversal. So those would be alternate interior angles. Alt-int, okay? Angles 6 and 3, those are the ones we've been working on most of the year, vertical angles. And 7 and 1 are also vertical angles. Okay, so hopefully that felt pretty good to you. But today we're going to be working on the relationship of these angles when these lines are actually parallel to each other. So let's look at a picture, okay? So I gave you two parallel lines. How do I know they're parallel? Well, these markings, these arrowheads we call them on the bar, if you see two arrowheads, it means these two lines are parallel. If you see one arrowhead, it means the lines are parallel. You could even see 3 arrowheads if necessary, depending on the number of lines. It tells me those lines are parallel. Now, typically when I use the arrowheads, I'm not going to also put arrows at the ends. My pictures I did, so I apologize for that. So if you see two that appear to be segments with arrowheads on them, please know they are lines, okay? All right, so when these two lines are parallel and they're cut by a transversal, I'm wondering if you notice anything about the different angles that I've marked here. I'd like you to take a second and I'd like you to write down a couple things that you notice or wonder. Pause and come back to us, okay? All right, so you're back. Now I'm hoping you've seen that there's a lot of really cool relationships going on here. It appears that angle A and angle E, which are corresponding angles, it appears that they are equal. And it also appears that angle C and angle G are equal, also corresponding angles. B and F appear to be equal, corresponding angles, and D and H appear to be equal, corresponding angles. And that is true. Corresponding angles are congruent if the lines are parallel. Now, you might also say, well, wait a second, Coach Fred. It seems like alternate interior angles are also parallel. And that's also another relationship I'm going to be going into in a second. Yes, C and F are congruent, and D and E are congruent. The weird relationship, though, is this D and F. Like, what relationship do D and F and E and C have? Well, if you notice, D and F, D and B actually form a linear pair. So, and B and F are equal. So therefore, D and F are supplementary because linear pairs are supplementary angles. So same side interior angles are supplementary. So same side sup. Okay. All right. So let's recap and let's get all this into our notes. The corresponding angle postulate basically says that if two parallel lines are cut by a transversal, then corresponding angles are congruent. All right, off to the right, I want you to draw a picture. So here we have two parallel lines. Let's cut them by a transversal. So draw a line that cuts through both of them. And angle 1, 2, 3, 4, 5, 6, 7, and 8. Let's name our angle pairs. So angle 1 is congruent to angle 5. Angle 3 is congruent to angle 7, Angle 2 is congruent to angle 6, and angle 4, so this should be 8, and angle 4 is congruent to angle 8. Those are all corresponding angles. So watch. 1, 2, 1, 2. I also see vertical angles, so then that's why those corresponding angles are all congruent. So we have all kinds of congruent angles when we've cut parallel lines by a transversal. All right, so then we have the alternate interior angle theorem. If we go back to that picture, we can see that all of our alternate interior angles, these 3 and 6 and 4 and 5, are also congruent. So if two parallel lines are cut by a transversal, then alternate interior angles are congruent as well. Okay, again, let me show you those alternate interior angles. Here and here, and here and here. Now, one thing to note when they're parallel, it's actually kind of nice to see. Alternate interior angles will form a Z, the top of which is the top of the Z and the bottom of which these have to be the parallel lines. So the top and the bottom of the Z have to be parallel, and it's the insides of those Z's that are congruent. Now, that can get confusing if I have to look backwards at it, like the other side, like these guys. It's still a Z, it's just a kind of a backward Z, like this. It's like a flipped around Z. So just remember, if you really get stuck, look for the Z's for alternate interior angles. All right, and then the last one we're going to talk about is the same side interior angle theorem. And that basically says that if two parallel lines, oops, gotta switch my pen, two parallel lines are cut by a transversal, then same side interior angles are supplementary, which means they add to 180 degrees. So same side supplementary, okay? Same side supplementary. All right, now let's talk about that. Here's two parallel lines cut by a transversal. So these guys are same side interior angles and they would be complementary or supplementary. And these guys are same side interior angles and they would be supplementary as well. All right, so a quick recap. If two parallel lines are cut by a transversal, then corresponding angles are congruent, which means equal. Alternate interior angles are congruent, which means equal. Same side interior angles are supplementary, which means they add to 180. All right, let's see if we can figure out the last one. Let's go back to that first picture. Alternate exterior angles. What do you notice about my markings that I came up with? You guessed it, same alternate exterior angles are also congruent, which means equal. All right, but we have to be able to use this. So let's look at an example. Here's some double sets of lines, but I see that I have parallel lines. I'm going to actually take my highlighter and I'm going to make it a little bit thinner, like this, okay? And I'm going to highlight the parallel lines. Because in this case, I actually have two transversals. I'm going to work with one at a time. Now, this first transversal, I have to pay attention. This is 130 degrees right there. So give that the degree symbol so that you can see it. All right, so I'm going to look for corresponding angles first. So corresponding angles would be here and here. So that means they're equal. So 130. That gives me that 3 is also equal, so 130. And 6 is also equal because of vertical angles. So that is also 130. All right, 1 and 2 are a linear pair. So they form a straight angle, which means they're supplementary. So right here has to be 50 degrees. If 1 is 50, then 4 is 50, because those are vertical angles. Notice the 2 hash marks. Okay, 4 and 5 are alternate interior angles, so those are also equal. So that would be 50. Now you might notice they're also corresponding with 1. All right, and then 5 and 7 are vertical angles, so also 50. All right, what about this little 8 over here? Well, I still have those parallel lines. I'll pretend this transversal is not even in my way, but now I have this transversal. So these are corresponding angles, so angle 8 would be 90 degrees. All right, let's look at another example. All right, I'd like you to go ahead and mark these lines parallel. Notice one set of arrowheads and these lines parallel. Notice I'm using 2 arrowheads. That indicates that these are the 2 that are parallel to each other. All right, so we got some work to do. I always want to start with the angle I'm given. I was given 110 degrees, so this angle right here. So 110 and 2z are corresponding angles. So how would I solve for z? Well, I'd write an equation, 110 equals 2z, and then I would divide by 2, giving me 55 degrees. All right, I want you to try y. Press pause and try it. All right, so we have to look at this sideways now. First of all, we know that this is 110 degrees. So these angles now, using these parallel lines, are same side interior angles. So that means they have to be supplementary. So 2y actually has to be equal to 70 degrees. See, it's a little tricky. So then y has to be equal to 35. Okay, now you could use that same idea here. If this is 110, then x has to be 70. Or you could have used these 2 parallel lines and saw that these have to be corresponding. Okay, all right, I'm going to stop there, and I'm going to ask you to try this one, okay? Try it and bring it to class tomorrow. We'll go over it in class, and we're going to do some harder ones, okay? All right, have a great night.